Okay, so I think I'm going to do the last 3 problems that I got on the same video here. I've got this limit. The limit is x goes to infinity is 16x to the 4th minus 3x, or sorry, plus 3x minus 2, all in a square root, all over 2x. This one is cubed plus 1. So what we need to look at is, once again, as with all of these infinite limits, we compare how the top grows compared to how the bottom grows. If the square root wasn't here and we saw this x to the 4th and the x to the 3rd, I'd say, oh, the top wins. But since the square root's here, that reduces that x to the 4th. If I take the square root of x to the 4th, well, that is going to be, square root of 100 is equal to, I could write 100 as 10 times 10, which gives me that the square root of 100 is 10, and we know that's true, and that's because you can write as 100 as 10 times 10. So x to the 4th can be written as the square root, of x squared times x squared. I know that's true because this is 4x is being multiplied, as is this. So when I square root that x to the 4th, I get an x squared. So that means that this right here acts like, when I compare it to this guy, it doesn't act like an x to the 4th or even a 16x to the 4th. It acts like a 4x squared. And the 4 comes from square root in the 16. So if that's really acting like a 4x squared and this is acting like a 2x cubed, then that means that the x cubed in the bottom wins. If I had a x squared, 4x squared over 2x cubed, that would reduce down to 2 over x, which would, as I go to infinity, this size is going to get bigger and bigger, which is going to make this thing smaller and smaller, which is going to make that limit equal to 0. So you should get 0 for that first one. Sorry, I just did all the work for the next one, and I didn't have a recording, so I'm just going to, undo, walk through everything I did. So for letter O, I'm looking at the limit as x goes to infinity of the same thing with a 2 here instead of a 3, so it's 2x squared. So as we talked about, the top here, it hasn't changed from there, so it acts like a 4x squared, this thing. So these guys are not going to matter, this is not going to matter. That's going to make this thing act like the limit as x goes to infinity of this piece, which is the 4x squared, over this piece, which is a 2x squared. These guys will cancel. The 2 will divide into the 4 and give me an answer of 2. So the last one, same thing, except for instead of a cubed or a squared, I'm now just down to an x. So this thing is going to act like the limit as x goes to infinity. Instead of this, I get a 4x squared, so we'll write it 4x squared over, it's going to act like that 2x. What's going to happen is as I divide the 2 into the 4, I get a 2, and if I divide this x into the x squared, I get an x. Well, I should write my limit. Yeah, so don't forget your limit notation, remember. So I get the limit as x goes to, oh, come on, man. Having trouble here. Limit as x goes to infinity of the 2x, because that's an infinity, which 2 times infinity, well, that's going to be a really big number. It's going to go to infinity. So what's my answer? It is infinity. So just to review, the answer to the first of these 3 was 0 because the bottom grew faster than the top. The answer to the second of these 3, right here, was 2, and that's because the bottom and the top tied in terms of their powers. So I square rooted the 16 on the way out to get a 4. Divide these guys out, I get 2. The last one, bottom grows like an x, the top grows like an x squared. That gives me this, which gives me that, which will explode as we move further out on the x's.